All right, awesome. Thanks so much for that, Dan. That was a really, I think, comprehensive and sort of nice tour. I am here to give maybe a more detailed code-based, feature-based tour of Istio 1.3. So last week, the 1.3 minor release occurred, and with that came some very exciting new features. I sort of got my hands dirty with 1.3 like last week, so I haven't been able to cover all of the features in the release notes. So I'm just going to try to highlight 5 or 6 of them. I would encourage you to check them out. Some really exciting stuff with usability, as well as performance and telemetry with this release. So it's good stuff. Okay, so what I'm hoping to do in this demo and to sort of take you from end to end. So I don't have any Istio installation right now. I've got nothing. I've got a cluster, and I'm going to try to go from sort of day 0 installing Istio to actually instrumenting it with an application using various new features in 1.3. So let's see if I am able to do this. So here's what I have to start with. And sorry if I keep going back and forth between slides and demos. I can just stop doing slides if it bothers you. Okay. So what I have to start here is a GKE Kubernetes cluster. Nothing special about it, just plain 1.13 default version of GKE. I have 5 nodes. It's running down South Carolina, US East 1B. And what I'm going to do here is I have a install script for 1.3.0 here. And what I want to highlight with this installation profile. So if you go into the Istio docs and you want to install it, generally the guidance will be use Helm template and then apply the YAML. What that lets you do is really easily set flags if you want to install Istio with any kind of setting. So Istio exposes a lot of these global flags like enable Coctl service graph or use a custom Prometheus installation. So what I've got going on here, the only sort of new thing is that I'm setting this global tag to use distro list images. And in Istio 1.3 came the ability to use distro list based images for all the Istio control plane features. What does that mean? It means that these are hardened container images of the Istio control plane that have things like package installers removed from the Docker container. You can kind of read up on this on your own, but it's sort of basically it's a more secure Istio installation is the point here. Okay, so what I'm going to do is I'm going to run the script, install Istio 1.3. Let me know if you can see this. On the right here in that other tab, so what's going on now is we're installing all the CRDs. There's going to be like 21 of them or so. And then we're going to watch all the Istio 1.3 pods kind of show up. I give my script like 20 seconds to get the CRDs in there. So the CRDs are the Istio config. So it's installing the idea of a virtual service onto the cluster right now. And here's the installation in all its glory. Those are all the pods. And if I were to do a describe on any of these control plane pods, I'd be able to see that the base image for pilot and for mixer is that distro list Docker image. So what I'm going to do is as this all sort of comes online, takes about 2 minutes, is go to my next feature. So not in 1.3, this isn't really anything new, but there's this open source service graph tool called Coctl, which is a super helpful way, just day 0, to see what's going on in the cluster. As part of this script, I deployed a sample app, and I can watch that get created here. And what I can do is open up Coctl and see what's running. But my IP is pending because I just installed it, but I'm going to wait for that to get created, that load balancer. Can everyone see my terminal okay here? Awesome. Great. I'm going to do a watch on that command. Oops. Can't use my aliases. Okay. Not here. Looking for it. Looking for this to get created. So on the right, just to give context, I've deployed a sort of sample application with like a dozen microservices, and as part of the installation, I exposed it through the Istio Ingress gateway. So it's just a demo retail app. It's got a checkout and a catalog and an email notification service. This helps us demo Istio because it's just enough services to be like, oh, that's more than one, that's more than two, but it's not so many that it's like totally overwhelming when you're talking to someone about it. Okay, let's go back to the terminal here, not my Spotify. Okay, great. So let's open up Kiali and see what's happening between all these services. Oops. Kiali runs on port 20,001 usually. I have a default secret. You can obviously lock it down with your own passcode, but so here we can select the default namespace, and here's the sample app that I just showed. So if you raise your hand if you know what Kiali is, because I don't have to. Yeah, I don't have to go through this whole thing. Okay, I'm just going to go through it for just a minute here. So what Kiali does is it exposes a service graph and a service list and visualizes your Istio config in a UI. So what we're showing here is the service graph for the default namespace. So I previously showed that this is the front end of our sample app, and a purple icon means that I've applied a virtual service, in this case to expose it to the public internet. And we're sending traffic load through a load gen pod from the front end into all of our various backend services. And triangles represent services, squares represent deployments. You can change it to just be a service graph if that's a little bit too busy. Green lines indicate gRPC traffic. Gray lines indicate TCP, or sorry, blue lines indicate TCP traffic. We can also look at just default metrics, so we can see all of the traffic is 200ing into the shopping cart service. Yeah, just basic metrics here. So that's Kiali. So we know what's running. That's great. Let's go into here. However, so you saw that I exposed a load balancer for Kiali. That took a couple seconds to happen. New in Istio 1.3 is this Istio Ctl dashboard command. It was actually experimental in 1.2, but it became not experimental in this release. And what I can do is do Istio Ctl dashboard Grafana and just see all of the default Istio dashboards really easily. What I want to show here is a couple of things. New in 1.3 are a few good dashboard improvements. The first one is for Citadel. There's now a dashboard for Citadel. So Citadel issues the MTLS keys for your Istio services. It's that component. So there's a dashboard for that, which is great. The other exciting thing is that the pilot dashboard got some awesome improvements in the 1.3 release. So pilot is responsible for taking your traffic config, converting that into Envoy API speak, and pushing that config down to your services. And what you can see in this dashboard is not just like the usage of the pod, but actually what is the frequency of those pushes down to those Envoy proxies. Yeah, as well as like all of sort of these Envoy specific metrics, which is pretty exciting. I definitely want to drill down more into some of this because I think it's really cool, especially if you're an operator and you're worried about things like, is Pilot able to handle all of the services I have deployed? Do I need to set up auto scaling, for example? So that's the new Pilot dashboard, new in 1.3. Okay, another cool Istio Ctl command that just got released into experimental this release is the describe pod command. And as DevRel, I'm extremely excited about this. Sorry, I'm just going to run this in the background, make sure I have it back someday. Great. Okay, so I've got these pods, right? This is my application on the right. I want to know what's the Istio config that's applied for these pods. Do they speak MTLS or do they speak plain text? I can run this Istio Ctl, spelling, experimental, describe pod, select any one of these. I'll just select the first one. Run this command, and Istio Ctl outputs this really helpful Istio-specific information, such as what are the containers that are in the pod, what ports are they running on, so just Istio-specific suggestions. It's asking me to add a version label to the pod. We know that the traffic is permissive, which means that it can handle both plain text and mutual TLS traffic, and we know that it's client-speak HTTP. And we know that it talks to a Redis database. I mean, this is so much information packed into such a small command. I think it's really cool. I'm excited to see sort of where it lands once it graduates from experimental. Okay, there's that feature. What's next? Port protocol detection. Okay, this was sort of hidden in the release notes somewhere because it's still somewhat experimental and it doesn't work for all protocols yet. but this is huge. So how many of you have tried to sort of instrument existing services with Istio before and ran into an issue where, like, if your port wasn't named the right protocol, Istio couldn't handle traffic for it? Okay, this is a very common day one use case where it's like, oh, I had my service, I injected Istio into the pod, and it broke everything. Usually the number one reason for that is port naming. A lot of times folks are using gRPC. What that meant is they had to add a port name for the service that was gRPC. Unfortunately for gRPC, you do still have to name it, but for HTTP and HTTP2, new in Istio 1.3 is the ability to not have to name your port. Istio will detect the port for you. This is extremely exciting. So what I have, so I only have one HTTP service in my sample app, but for the one that was, I removed the port name, and Kiali and Istio were still able to detect that the traffic was HTTP. I think I'm very excited about this. I'm hoping that our users are too.
I can verify that this is something that Tristan thought over.
Yeah.
I'm excited to stop getting support.
Yeah, I think for sure. Yes. Okay, port protocol detection, exciting stuff, new in 1.3. Another very exciting thing. So we talked a little bit about Pilot and its important job in Istio. New in 1.3 is a up to, as reported in the release notes, 90% reduction in Pilot CPU utilization. So that's an up to, right? It depends on the deployment, depends on your scale. I wanted to test this out for myself. So earlier today, so I have an Istio 1.2 Kubernetes cluster running with the same sample app, and I have this 1.3 cluster running with the same app, and I opened up the Pilot Grafana dashboard and looked at the CPU usage for Pilot. And what I saw, so this is Pilot CPU at like 3 o'clock today. We're seeing, I think this is in cores, so we're seeing like, up to 10 millicores for Pilot, which it's not a very big app, so yeah. But here's 1.2, almost like twice that. Right, so this makes me really excited to load test sometime this week to actually see, like, can I see up to that 90%? I'm going to challenge myself to see, because if it's not, I will demand that the release notes be updated. Just kidding. Okay, I've sort of left the most exciting things perhaps for last. How many of you are familiar with like the mixer component of Istio? So, right, so Istio has the pilot piece, which is kind of for traffic, Citadel, which is kind of like for security, mixers for telemetry. Its job is multiple, but part of its job is to ingest metrics and get them to various backends, such as Prometheus, Stackdriver, as we know. New in Istio 1.3 is the beginnings of something called Envoy native telemetry. What this means is that the sidecar proxies themselves can forward metrics from your workloads directly to the backend telemetry service of your choice. So that correctly described Envoy? Okay, that's Envoy native telemetry. This is huge for performance. I mean, if you're a major customer and you actually want to get this up and running in production, Mixer tends to be the first thing that comes up as far as like, well, it's not quite at the performance we need for the scale that we have. So this is huge, being able to go direct from Envoy to Prometheus. What I'm going to try to do live right now is disable Mixer telemetry, turn it off, enable Envoy native telemetry, go back into Grafana and see if we can get metrics directly from. So I tried this once today. We'll see if it works. There's no magic here. So what I'm going to do is just create a new YAML where all I'm doing is I'm saying Mixer telemetry enabled equals false. Then I'm going to delete Istio telemetry, which is Mixer. Then I'm going to apply these custom Envoy filters, which allow the Envoy native telemetry to happen. That's all I'm doing. I'm going to run this command here. Now on the right here, what we'll see is Istio telemetry is going to go away. It's gone. Istio policy is still there, but we're not using that. Terminating. Okay, it's gone. Okay, we can see this Envoy filter, metadata exchange, and stats filter. You can read up about how it's working exactly. And then I think I still have my Grafana dashboard up. We're going to go into the service dashboard for Istio. So Dan talked about this sort of magical thing that Istio can do from the Grafana side, which is create these service dashboards on your behalf for all the services you have, because we're using the same protocol for telemetry. So what we can see, okay, so there is a small bug that I haven't reported yet, but the way that things are getting reported in Grafana, when I had Mixer, they were getting reported as cart service default cluster local, which is the long name of a Kubernetes service. And with Envoy native telemetry, they're getting reported as short name port. I'm going to file that. It's going to be fine. But what we see is things dropping off moments ago for cart service.default.cluster.local. If we go into cart service 7070, we can see starting, what was this? This minute, metrics start to come in from Envoy. I thought this was really cool when I tried it for the first time. It's cool because there's no Mixer, but we have telemetry. Sorry, as someone who's worked on Istio for the last year, it like blew my mind.
Why is it cool to not have Mixer?
Because you don't have to deal with the added latency that Mixer adds.
Well, it's all, I mean, Megan is right, it's a big deal. So Mixer is one of the biggest scaling issues especially in telemetry, because if every pod that has an Envoy sidecar, there's these golden metrics about it. So you've got half a dozen metrics at least. But the metrics are also not just so many metrics for this pod, but every single different pod that might send to it. Every single different pod it might send out to, right? Because we're keeping track of the cross product of every possible source and destination. So you have a combinatorial explosion of data at every single pod. Each one can handle that. And you got some pod and a dozen things are talking to it, it's talking to a dozen other things, you have some, some factor, times 6, you get some factor there. One process can handle that. But try to take all of that from every single pod and funnel that all into one process, which is the mixer. And now, well, heck, maybe you were fine when you have 10 pods. When you have 100 pods or 1,000 pods, it suddenly is very, very expensive. So we regularly would have problems where the mixer would get overloaded and so when telemetry died. And well, it's because this process is running out of memory or is a performance bottleneck and stuff like that. So, what this does, and then you go, okay, well, I'm going to need 2 mixers. And so you keep, or I'm going to need more memory in the mixer. And so you keep fiddling with this wedgy little mixer, just to get your performance telemetry out, which is, you usually want to a fire, and that's not what you want to be doing. What this does is it removes that choke point. So now each Envoy, which can totally handle its own little bit of telemetry, can just send it directly to the backend, the telemetry backend, which telemetry backends know how to scale in 9 ways to Sunday, so it's not really a problem there. It gets rid of that choke point. What's the biggest single choke point for scaling these two?
That's a long way of what I was going to say, which is scalability.
Yeah, okay. It's more scalable. Right, I should have led with that.
Both the changes that you talked about in pilot and the changes running into big problems. This is making the whole system use a lot less resources and therefore
for example, integrating this. You're actually using a policy unique to the example because it was policy than this segment. We kind of copy your policies, now have access to the policy.
this is just telemetry for now. That's policy. Yeah, this is just telemetry.
All right, so I mean, the architecture allows for this.
Sorry.
Awesome. No, this is great. Just to recap for folks on the recording, I think we heard scalability, reduce latency for Envoy, and yeah, just increased performance, and in the future, improved policies on that. Great. All right, so that's Envoy native telemetry. Those were kind of all the features I had time to sort of explore and demo for 1.3 so far. I did want to add one cool bonus demo of something I learned that Istio could do recently. I don't know why I didn't know this before, but did you know that Istio has the ability to inject response headers into your service requests? So it can remove them, it can strip headers, it can also add them. I was talking to a user last week who had a very interesting use case for this. This is not new in 1.3. I just added it an hour ago. They use a CDN, like Fctl or some other CDN, and they have a lot of services. And Fctl has this header that it uses to determine whether or not it should cache a request or not. And they had just brought another service online, and they didn't want to cache these requests, and they were already using Istio, and they were like, Istio can do things with headers. It can look at the headers. Can it manipulate the headers? The answer is yes. So last time I'm going to show is adding a cache false and also a Hello New York header to all requests to the front end. So sorry that this was kind of telemetry focused. Here is a traffic demo to sort of close out here. So let's see. What I'm doing here, so if you're not familiar with the Istio config model, the idea is to control traffic. You add a virtual service CRD. It's a YAML file with a rule. What I'm going to do is modify the front-end ingress rule to say headers, response, add, and it's just a key value map of headers. Okay, and just to prove that I'm not faking here, I'm going to curl -i, sorry. Having trouble seeing my, yeah, that looks right. Curl-i front end. I can see here's all the headers I get just because they're sort of by default. It's some Istio injected headers. What I'm going to do is I'm going to apply the YAML, my alias there, and I'm going to run the same curl. We can see that the headers are there. It's just like a cool thing I learned this week. Like, I feel like there are so many other use cases of this. If you ever want to learn more about it, it's kind of hard to find. But I will show you where in the docs you can find the documentation on this, because there is documentation. Let's see here: reference, configuration, traffic management, virtual service, headers, header operations. So the header, there is an example in the docs of removing headers. If you want to learn about that, there was not an example of adding headers, so I'm going to try to add one. Okay, that was the bonus demo. Questions?
Where I can go to find the example.
Yes, I write examples at this website, istiobyexample.dev, where you can learn in very small bits how to do small things, and also not so small, like encrypt all your traffic with Istio, and all the docs refer to the longer Istio docs if you want to drill down deeper. Istiobyexample.dev. Thanks, Dan, helping me get traffic to my website. Okay, any questions? Thank you for humoring me through all those fun demos.
Thank you, Megan.
Yeah, no problem.